Welcome to the deep dive. It's a really funny thing to think about, but back in 2017, a milestone was reached that just completely broke the historical rules of business.
Oh, absolutely. It changed everything.
Right, because the absolute largest hotel company on planet Earth didn't own a single hotel room. Not one.
Yeah.
But here's where it gets really interesting. And this comes straight from the startup case studies and architectural blueprints you, our listener, sent in for us to look at today. To run that massive global empire, they didn't own a single physical computer server either.
It sounds almost like a riddle, doesn't it? Like
Yeah.
a real estate giant with absolutely no real estate and a technology giant with no physical hardware.
Exactly.
But I mean, it perfectly captures the reality of the modern digital economy. We are operating in this world where the fundamental constraints of building a business have just been completely inverted.
And that is exactly our mission for today's deep dive. We are going to explore exactly how tech empires like Airbnb and Dropbox were built from a single laptop using AWS, or Amazon Web Services.
Yeah, the cloud.
Right. We're getting into the architecture, the economics, and the actual mechanics of cloud scaling from your notes. We'll look at why the infrastructure decisions you make on day one can either, turn you into a billionaire or literally crash your company on launch day.
Because if we connect this to the bigger picture, to really appreciate the stakes here, we have to look at what infrastructure meant before the cloud paradigm took over.
Oh, it was a nightmare.
It really was. Building the back end for a global tech company used to be, well, indistinguishable from building a physical manufacturing plant. It took years.
Wow. Yeah.
It required massive upfront capital expenditures. You had to go out and lease commercial data center space, order physical server racks, wire up the networking, configure the subnets. I mean, the list goes on.
You essentially had to be an electrician and a cooling expert, too.
Exactly. You're installing industrial cooling systems and hiring specialized ops teams just to ensure a random power fluctuation didn't take your entire application offline. But today,
Yeah.
that exact same foundational power takes a few weeks, a laptop, and an API call.
It is the ultimate shortcut, and we see this play out perfectly with the Airbnb origin story from 2008, which was in the case studies you provided.
Well, the air mattress story.
Yes. 3 guys in a San Francisco apartment literally renting out air mattresses because they couldn't afford their rent. But to turn that quirky idea into a real marketplace, they suddenly needed the digital infrastructure of a global enterprise.
What's fascinating here is how the cloud acted as a great equalizer. I mean, think about the technical complexity of what they were trying to build.
Right. It's not just a simple website.
Not at all. They needed a highly secure environment to process international payments. They needed caching layers for these complex user profiles. They had to serve millions of high-resolution property photos globally and with super low latency.
Which takes a massive amount of power.
And they needed a search algorithm capable of instantly filtering dynamic inventory by date, geographic radius, price points. Historically, provisioning the hardware for that stack would require a massive engineering department.
And a huge budget, which they definitely did not have.
Zero capital. They had absolutely nothing.
But they had access to AWS. So right off the bat, they bypassed the data center entirely.
Yeah. AWS allowed Airbnb to launch their core platform without waiting like 6 months for a server cluster to clear customs and be racked. They just spun up virtual instances in Amazon's data centers.
Just clicking a button, basically.
Exactly. And as they grew from 3 initial users to eventually over 100 million, they didn't have to pause their growth to build new physical factories. They just adjusted their provisioning limits and scaled horizontally. It shifted.
Because what if your core product actually is the heavy infrastructure? What if you are building a file storage company?
Right.
I'm thinking about Dropbox in 2007. 2 MIT students who want to store files and seamlessly sync them across multiple devices. Building a global storage array from scratch is a whole different beast than running a web server.
It is fundamentally different. Managing petabytes of raw storage requires dealing with hard drive failure rates, RAID array rebuilds, and massive data replication across geographic zones.
Sounds expensive.
It's a logistics nightmare. It usually requires a highly specialized hardware team.
So they do something brilliant. They bypass the hardware problem entirely by building on top of S3, Amazon's storage service. I look at this and I think of this analogy.
Let's hear it.
It's like wanting to start a massive global restaurant chain, but instead of spending tens of millions of dollars building commercial kitchens in every single city, you just find a massive industrial kitchen that already exists, and you rent a single stove burner by the hour.
That is a highly effective way to visualize it. I like that. They utilized S3 not just as a backup, but as the core foundational layer of their entire product.
Right, they didn't build the kitchen.
No, S3 provided an infinitely expanding, highly durable object storage system that they just accessed via API. The founders didn't have to procure storage arrays or worry about disk degradation. They just paid a fraction of a cent for every gigabyte of data they pushed into the bucket.
So the early Dropbox product, the thing that absolutely wowed the tech world and attracted millions of users, was essentially a beautiful, incredibly user-friendly interface layered right on top of Amazon's infrastructure.
Exactly. They didn't reinvent storage.
Right. They built a native desktop client with an incredible Delta Sync algorithm, and then they just pointed all the heavy lifting at AWS.
It was a masterclass in focusing on your unique value proposition. Dropbox's genius wasn't in spinning magnetic disks. It was the conflict resolution in their syncing software.
Making it feel seamless to the user.
Yes. By offloading the raw storage management to AWS, they could dedicate all their engineering cycles to making the local user experience feel like magic. It allowed a tiny team to offer enterprise-grade file durability to the entire world.
Okay, let's unpack this.
Yeah.
Because we are hitting a massive plot twist in the blueprints you provided.
Oh, here we go.
If AWS is this holy grail of startups, right? If it's the magical industrial kitchen you can rent by the hour, why did Dropbox eventually spend tens of millions of dollars and countless engineering hours to migrate completely off of AWS 10 years later?
It comes down to the brutal realities of raw economics at a massive scale. It is the ultimate scaling paradox.
Explain the mechanics of that, because it feels completely counterintuitive. I mean, if the cloud got them to $1 billion valuation, why go through the immense pain of abandoning it? Changing out your entire storage infrastructure mid-flight seems incredibly risky.
It is risky, but convenience and elasticity always come with a premium. Let's stick with your industrial kitchen analogy for a second.
Okay, yeah.
Renting a stove burner by the hour is fantastic when you're testing recipes, or serving 50 customers a night, or even when your customer count fluctuates wildly from day to day. You only pay for what you use.
Right, makes sense.
But what happens when you are serving 50 million meals a day, every single day, with absolute unyielding predictability?
Oh, you're suddenly paying an astronomical hourly rate for a burner that is literally never turned off.
Exactly.
You're effectively subsidizing the landlord's profit margin instead of building your own equity.
Precisely. AWS charges a premium because they provide infinite flexibility. You can provision 1,000 instances for a load test at 2 p.m. and terminate them all at 3 p.m.
Which is amazing when you're small.
Right.
Yeah.
But once Dropbox hit a massive, predictable global scale, their storage needs weren't fluctuating in unpredictable spikes anymore. They knew exactly how many petabytes of data they needed to store, and their growth curve was just a steady, predictable line.
So the flexibility wasn't helping them anymore.
Not at all. The elasticity of AWS was no longer a benefit. It was just a massive tax on their gross margins.
And the numbers back this up. Because when Dropbox built their own custom infrastructure, racking their own bare metal servers and routing their own network egress, they saved $75 million per year.
$75 million annually in pure profit added back to their bottom line.
That is insane.
It is. And the core lesson here, and it's honestly one of the most widely misunderstood aspects of modern tech infrastructure, is that the cloud is the absolute right answer at the start, but it isn't necessarily the right answer forever.
Right.
Owning your own hardware only makes financial sense when your baseline load is so massive and so predictable that the raw economics demand a shift from OpEx back to CapEx.
So you outsource the infrastructure early on so you can move at the speed of light. But later on, if you actually manage to become a titan, you insource the infrastructure to protect your margins.
Exactly. But successfully reaching that titan stage means you have to survive your initial hypergrowth phases. And that means engineering your cloud architecture correctly from day one, so that you don't collapse under your own weight before you ever reach scale.
Which brings us to the darker side of cloud computing from the case studies.
Yeah, it's not all success stories.
Let's talk about how to engineer your own downfall. We've seen how to build an empire. Now let's look at the cautionary tale. You shared this scenario of a startup that made absolutely every architectural mistake possible, ultimately crashing their systems on launch day.
It's a painful one to read.
I want to walk through this, but first I need to push back intelligently here.
Wait, great.
Wait, AWS auto-scaling is specifically designed to prevent this, isn't it?
In theory, yes.
Because you set up an auto-scaling group, traffic spikes, CPU utilization hits a threshold, and AWS automatically spins up more servers to handle the load. So if a startup crashes on launch day when they go viral, it's not a cloud failure, is it? It's an architectural failure. What are they fundamentally misconfiguring that makes the cloud drop them?
That is the exact right question to ask, and it highlights the biggest misconception about cloud scalability. The cloud is not a magic wand that fixes bad architecture.
Right.
To use another analogy, imagine you build a highway system. AWS gives you the ability to instantly add 10 more lanes to the highway when traffic gets heavy. That's your auto-scaling group adding web servers.
Okay, I follow.
But if all 10 of those lanes funnel into a single one-lane toll booth at the very end, what happens?
You get a massive traffic jam anyway.
Exactly.
The extra lanes didn't alleviate the bottleneck. They just delivered the traffic to the bottleneck faster.
Bingo. In web architecture, that toll booth is almost always the relational database.
Okay.
See, web servers are generally stateless, meaning they don't hold permanent data. They just process requests. Because they are stateless, you can clone them infinitely. Databases, however, are stateful. They hold the actual data, the truth of your application.
Right, the actual user accounts and stuff.
Yeah. Traditional relational databases like MySQL or Postgres run on a single primary node that handles all the right requests.
So the startup, in our case study, they built a system where the web servers could duplicate themselves infinitely, but they were all trying to read and write from one single database instance.
Exactly. And they load tested their system for 1,000 concurrent users, and everything looked completely fine.
Because at 1,000 users, the database can handle the connections.
Right. But then they went viral. They got featured on a major tech site, and 100,000 users hit the application all at once.
Oh boy. So the web servers see the traffic spike, the auto-scaling group triggers, and suddenly you have 100 web servers spinning up to handle the load.
And every single one of those new web servers instantly tries to open hundreds of new connections to the single database. They hit connection pooling limits. The database CPU spikes to 100%, trying to manage table locks and write requests.
And then
The database freezes.
the toll booth shuts down. And because the web servers can't talk to the database, they start returning 500 internal server errors to the users.
And this triggers a cascading failure. The auto-scaling system sees that the web servers are struggling to return successful requests, so it assumes it needs more compute power.
Oh no, it adds more servers.
Yes, it spins up even more web servers, which hammer the dead database even harder. The entire application is completely unresponsive.
And to make it infinitely worse, this startup made another fatal flaw. They didn't configure billing alerts or set maximum capacity limits on their auto-scaling.
This is the absolute nightmare scenario in cloud computing. In a traditional data center, your maximum cost is capped by the physical hardware you bought. In the cloud, you pay for what you provision.
The meter is running.
If your architecture panics and spins up 50 high-powered memory-optimized compute instances and you lack a circuit breaker to scale them back down, the meter just runs at maximum velocity.
So the website is completely offline. They are losing tens of thousands of potential users by the minute. And simultaneously, they are racking up an astronomical AWS bill for servers that are doing nothing but generating error logs.
It's brutal.
Paint the picture of that brutal post-mortem conversation with the investors. I mean, you're sitting in a boardroom having to explain that you finally got the viral moment you've been pitching for 2 years, and you not only failed to capture a single user, but you also blew through an entire month's worth of runway in 6 hours.
The profound tragedy of that boardroom meeting is that a few foundational decisions could have completely mitigated the disaster.
Like what?
Implementing a managed database designed for horizontal scaling rather than a single monolithic node. Setting a hard cap on the auto-scaling group. Implementing a simple billing alert threshold.
Just basic safeguards.
Exactly. Running a load test that simulates a highly aggressive, bursty traffic spike rather than a gentle ramp-up. These aren't million-dollar engineering fixes. They are architectural choices that must be made on day one.
So what does this all mean? We've explored the initial miracle of Airbnb's rapid deployment, the intense margin-saving pivot of Dropbox, and the architectural nightmare of the startup that choked on its own success. When you analyze the companies that actually survive hypergrowth and scale gracefully, there is a clear, definitive pattern.
There's an ultimate thread, yeah. And it serves as the golden rule for modern technical architecture.
Let's hear it.
The blueprint for scaling to billions essentially boils down to three distinct phases. Start serverless, scale to managed services, and only own your infrastructure when the economics absolutely demand it.
Break down that first phase for me. Start serverless. Explain the actual mechanism of that, because the word itself is honestly a bit confusing.
It really is. Serverless is definitely a misnomer. I mean, there's still physical servers sitting in an Amazon data center,
Yeah.
but you don't manage them, provision them, or even see them. In a traditional model, you rent a server, and it sits there running 24/7, waiting for a user to visit. You pay for it, whether it's processing a million requests or zero. In a serverless model, you just write your code, package it up, and hand it to AWS.
And the code only executes when an event triggers it.
Right. When a user clicks a button on your app, AWS instantly spins up a tiny, ephemeral microcontainer, runs your code for a few hundred milliseconds, returns the result to the user, and then completely destroys the container.
Wow.
You are billed purely for those milliseconds of execution time. If no one visits your site at 3 a.m., your compute bill for that hour is literally zero.
That immediately eliminates the meter running nightmare we discussed with the failed startup. If the site is idle, you aren't paying for idle capacity.
Exactly. Then, as your user base grows and your traffic patterns become more constant, you move into phase two. Managed services. You might graduate to needing a dedicated database instance or more persistent compute resources. But you pay AWS a premium to manage the heavy operational lifting, the security patches, the automated backups, the multi-zone failovers.
So you're paying a bit more, but you're saving on a headache.
You willingly trade a little bit of your gross margin to keep your engineering team focused entirely on improving your product rather than maintaining the plumbing.
And then phase three, the Dropbox phase. You only buy the plumbing and rack your own physical servers when your monthly AWS bill gets so staggeringly high that it makes financial sense to build your own water tower.
That is the complete life cycle of a modern technology company.
So I have to ask you the ultimate $0 billion-dollar question. Based on this three-phase blueprint, could you theoretically build a billion-dollar company on AWS today, starting with $0?
My honest assessment?
Yeah,
Really. In fact, it is significantly easier to do it today than it was when Airbnb or Dropbox were founded. The abstractions are infinitely more powerful. AWS and other major cloud providers offer generous free tiers that give you enough compute power, storage, and database capacity to build a fully functioning prototype.
So you could handle actual users for free.
Yes, you can serve your first few thousand users without paying a single dime. The barrier to entry is no longer access to capital.
That is incredibly empowering. I know you, listening to this right now, might have a side project idea bouncing around in your head. So connecting all this architectural theory to practical application. If you want to launch that idea today, what is the absolute minimum AWS setup to get it off the ground, ensuring it can scale if it goes viral, but without risking a surprise $10,000 bill?
You keep it strictly to the three-service minimum viable launch.
Okay, what's step one?
First, you need storage for your static assets, your compiled front-end code, your images, your style sheets. As we discussed with Dropbox, use S3 for that.
Makes sense.
It's incredibly cheap, highly durable, and it serves web assets directly without needing a web server in front of it.
So S3 handles the front-end UI. What about the back-end logic, the actual brain of the application?
Second, use serverless compute for your API and business logic. In the AWS ecosystem, this is Lambda.
Lambda.
You upload your functions, and they only run when a user interacts with the app. You get 1 million free requests per month on the free tier.
1 million. Wow.
And crucially, because Lambda scales out automatically by spinning up parallel independent executions, you don't have to worry about configuring auto-scaling groups or managing connection limits on the compute layer.
1 million free requests. Okay, and third, how do we avoid the relational database toll booth that crashes everything?
Third, you use a fully managed NoSQL database like DynamoDB. DynamoDB operates on a fundamentally different paradigm than a traditional SQL database. Instead of a single primary node handling all the writes, DynamoDB partitions your data across multiple physical storage nodes under the hood based on partition keys. As your traffic scales, AWS automatically distributes the load across more nodes.
So no toll booth.
Exactly. It provides single-digit millisecond performance at virtually any scale.
So S3 for the static front end, Lambda for the event-driven brain, and DynamoDB for the infinitely scalable memory. It's a clean, decoupled architecture.
Very clean.
It is virtually free to start, and it inherently solves the toll booth bottleneck, meaning it is theoretically capable of scaling to millions of concurrent users without you ever having to provision a single piece of hardware.
That three-service setup represents the pinnacle of modern cloud abstraction. It is the most capital-efficient, risk-averse way to test a software idea in human history.
We really are operating in a completely different paradigm. We've traced the journey from three founders desperately relying on borrowed digital space to launch Airbnb, to MIT students faking massive storage arrays with local sync clients, all the way to Titans saving $75 million a year by bringing operations back to bare metal.
It's a wild ride.
And we've outlined the exact step-by-step architectural blueprint for taking a side project from zero to scale without ending up in a dreaded investor post-mortem.
It's an incredible technical evolution. And, this raises an important question, something for you to ponder long after this deep dive concludes.
Let's hear it.
We've established that cloud computing has completely democratized the means of production for software. It has removed the technological barriers, and it has removed the financial barriers to building massive, globally scalable infrastructure.
So if you no longer need millions of venture capital dollars, or a dedicated hardware team, or a physical server farm to build the next global tech empire.
Right. What is the actual bottleneck for innovation today? If the friction of capital is gone and the friction of hardware provisioning is gone, is the only bottleneck left simply human imagination? Are our own ideas the only limiting factor left in the equation?
That is a phenomenal thought to leave on. We started this deep dive talking about an invisible empire, the largest hotel company in the world built entirely on servers they didn't own. The infrastructure of the future is invisible, which means the only thing that actually matters now is the quality of the solution you build on top of it. Thank you for joining us, and thank you for sharing these incredible case studies. This was a blast to unpack. Keep digging, keep building, and bring your next stack of notes for another deep dive soon.